Many technological advances have been made in the past century, from steam engines to the smallest of integrated circuits. Nowadays, microchips are developed for small gadgets and devices. These small miniature trays of various intricate materials are made from different metal and polymer components. The base material of these integrated chips is called the silicon wafer, on which the transistors rest. These wafers, before sliced into thin rectangles, are like the size of a compact disc with a thickness of that of a paper. Silicon wafers are thin slices of semiconductor material such as a silicon crystal. Semiconductors are solid substances that has a conductivity between that of an insulator like ceramics and that of most metals, either due to the addition of an impurity or because of temperature effects.
Origin of silicon wafers. In 1954, silicon becomes born in the transistor industry when Texas Instruments produced the first commercial silicon transistor. Silicon wafers are formed of highly pure, nearly defect-free single crystalline material. One process for forming crystalline wafer is known as Sokralski growth, invented by the Polish chemist Jan Sokralski. In this process, a cylindrical ingot of high-purity monocrystalline semiconductor, such as silicon or germanium, called bowl, is formed by pulling a seed from a melt. Zone melting is a group of similar method of purifying crystal, in which a narrow region of crystal is melted, and this molten zone is moved along the crystal. The bowl is then sliced with the wafer saw and polished to form wafers.
Okay, so properties of silicon wafers. So silicon wafers are 100% pure factory-made wafers imbued or infused with silicons. First property of it is it does have high resistance, but its resistance is much lower compared to that of an insulator. When making silicon wafers, we can alter its conducting property by the process of doping. So first, what is doping? Doping is a kind of process where a specific silicon wafer, which is 100% pure silicon wafer, is being exposed into vapors and phases of different elements such as silicon, arsenic, lead, and other elements that is used in doping, whether it is acceptor or donor of electron properties. In doping, a silicon wafer is being exposed to heat of 600 to 800 degrees Celsius, and it lasts for about 6 to 12 hours depending on the needed conductivity of a specific silicon wafer. And last property of it is it is very high, it is very sensitive to light and heat, because in doping it's being exposed in high heat, which alters its conducting property. So maybe, just maybe, it is very sensitive to high heat and light, because such high heat and light exposure may tend to alter its conducting property as per doping, and maybe the silicon wafer will, and thus making the silicon wafer malfunctions in a certain integrated circuits, because silicon wafer is being used on such electronic devices and computers and cell phones and laptops and such.
The structure of silicon wafer are available in a variety of diameters from 25.4 to 300 millimeters depending on its purpose. It is measured to its center and not through any flats. It is also stated that the thickness of the silicon fiber is around 275 micrometers to 975 micrometer. The thickness of the silicon fiber is determined by the mechanical strength of the material. The wafer must be thick enough to support its own weight without cracking. The crystal lattice of the entire solid is continuous, unbroken to its edges and free of any grain boundaries. It goes to show that the silicon fiber has great electrical property, at the same time has great insulation. That is why it is widely used on our generation, and it greatly contributes innovation in the field of technology.
For the applications and uses, have you ever heard of a computer called ENIAC? It was about the same length and weight as 3 to 4 double-decker buses and contained 18,000 buzzing electronic switches known as vacuum tubes. So before, there was no uses of these silicon wafers. It was not yet introduced to the market. It was not yet produced. That's why people before that time they use some vacuum tubes to manipulate some machines. But now we are integrated by what we so call the integrated circuits that we are using now to our gadgets, and this makes our life more easier.
Origin of silicon wafers.